Hello all, I am Arya Sir Alex and I am going to conduct a seminar on the topic RF identification in healthcare. And these are the table of contents that I will be going through. First of all, the introduction, then a general idea about what RFID is, its history, how RFID is used in healthcare, its application, the advantages, limitation, conclusion, and finally, all the reference used. Okay, so we are in an age where there is a rising cases of health emergencies and deadly pandemic. So it is really important for a country to enhance its health infrastructure. So in this case, RFID is applying, constructing and better efficient healthcare system that offers various healthcare services and benefits healthcare personnel and patients. Now moving on to what RFID is. RFID or radio frequency identification is what basically refers to a wireless communication system. It basically comprises of two components, which is the tags and the readers. So the readers are usually stationary and it is kept at the point of contact, and the tags are which we give to the people who want to use it. Using the users have the tags in their hand. So the basic working is that the RFID tag is attached to assets which transmits store data to the antenna. The antenna is connected to the RFID reader. The antenna receives the stored data from the tag and transmits that data to an RFID reader. The RFID reader is then connected to the antenna and as well as to the computer database, which receives the data from the RFID tag. The computer database basically has the data which is analyzed and scrutinized through the already erected computer database itself. So let's move on to the history of RFID. If you were to go back to the origin of RFID, we would go back to the 1940s to the invention of radar. The radar technology was a basic means of communication during the World War technology. It happened after the aftermath of the invention of radar, and in the 1950s, the first theoretical framework of RFID happened. A general idea about what RFID was and how it could be used in various applications. The 1960s saw the use of the first practical RFID system. Mostly it was a passive RFID system, which later on in the 1970s led to the development of active RFID system. And in the 1980s, commercialization of RFID system came into being. That is, other than the government officials and stuff, RFID were used in much more common, and the public were in use of such RFID systems. The 1990s saw the standardization of RFID through the EPC protocols. In the 2000s, the UHF RFID was introduced. In the 2010s, the near field communication was introduced, and in 2020s, the ongoing developments are the advancements in miniaturization of the chips, the enhancement of the security, data analytics, and such. So the next slide explains how RFID works. So RFID, as the name suggests, uses electromagnetic fields for the communication by identifying and also track tags that is attached to a specific system unique to the tag. As mentioned earlier, an RFID system consists of an RFID tag. Given us a picture of an RFID tag, it is a small electronic device that contains a unique identification number or other data. That is, each tag has a specific number, has a unique number that is compatible only to a specific reader that is of the same system. There are basically two main types of RFID tags, one being passive and the other being active. The main difference between them being how they power the tags. That, for example, they can either use a battery that is inbuilt in the tag, or they have to be charged continuously through the process of fusing of the system. Next is the RFID reader. As mentioned earlier, each RFID tag is compatible only to a specific reader. So the RFID reader is a device that sends out radio signals and receives data from the RFID tags. A reader emits radio waves in a certain frequency range. The frequency range is typically of 125 kilohertz, 13.56 megahertz, or 900 megahertz. It completely depends on what type of the RFID system you are using. Ultra high or just the medium high or whatever system you are using, the frequency range differentiates on basis of that. So this basically creates an electromagnetic field around it, and that is what indulges in the communication between the system. The other parts of it being the data processing and the software. So data is collected from the interaction between the reader and the tag. The data collected from RFID readers are fed to electronic components, which can be microcontrollers and processors. These are fed to microcontrollers and processors, and the data is then analyzed by the software which is inbuilt in the microcontroller. It integrates it into broader systems. Moving on to data transfer, that is how data might transfer between a tag and a reader. So when a passive RFID tag enters the electromagnetic field of the reader, which is compatible to the tag, it absorbs some of the energy from the reader signal, which powers the tag temporarily. The powered RFID tag then uses this energy to transmit its data back to the reader by modulating the radio signal it received. The data encoding and decoding. So once the data is got through the interaction between the tag and the reader, these data has to be encoded and decoded for effective communication. So there are various encoding methods that are used to store and transmit the data, which includes binary phase shift keying and others. The reader, which captures the data, transmits by the tag and decodes it. So after the working of how RFID is done, let's move on to the frequency band and how frequency band differentiates one RFID system from another. So RFID system usually operates in different frequency bands as mentioned earlier, such as it can be a low frequency band, or it could be a high frequency or a ultra high frequency and microwave band. Each frequency band has specific antenna designs optimized for its characteristics. That is, the frequency bands can be different, and how the data used and how the data can be scrutinized for each band is different. So the antennas that is used for the communication will be different based on how different the frequency bands are. Now let's discuss about the antennas that we use for different frequency bands. So, giving a general idea about antennas, antennas are essential components that transmit and receive radio waves, allowing for the identification and tracking of objects or individuals. So, first of all, for the low frequency antennas, that is the low frequency means between 125 kilohertz to 134 kilohertz. So the antennas used is the ferrite rode antennas. So as seen in the pictures, they are an iron rod which is worn by a wire. These are often used for LF RFID system, and they are commonly found in LF RFID readers for applications like access control, animal tracking, etc. Next is the high frequency antennas, which is in the range of about 13.56 megahertz. So in this range, we use coil antennas. The high frequency RFID systems often use circular, or it could be even rectangular coil antennas. These are generally coils which is wound in a specific shape. They can be embedded in smart cards, integrated into access control system, and can be also used in near field communication devices. Next is the ultra high frequency antennas. The range is being from 860 megahertz to 960 megahertz. So there are different examples that I have cited here, being dipole antennas, Yagi antennas, and patch antennas. So dipole antennas are the most common used for ultra high frequency RFID systems. They come in various shapes and sizes, including linear and patch antennas. So they are used in applications such as inventory tracking and supply chain management. The second one being Yagi antennas. As you can see from the picture, this is the one we are most familiar from what we have used over the years. They have directional properties, that is, they can be used for communication in specific directions and are used in long range UHF RFID system, especially in applications like toll collection and vehicle tracking. The third one being patched antennas. As we see in the picture, there is a central rectangular area which is a patch that is connected to the feed, and the patch and the feed is surrounded by a dielectric. They are often used in RFID readers for their compact size and the efficiency. They are suitable for both short range and long range UHF applications. Now let's move on to the communication protocols that exist. So the RFID systems use communication protocols to facilitate data exchange between readers and tags. So some common RFID communication protocols include ISO IEC 1443. This is an international standard that defines proximity cut standards for contactless communication. So the specific protocol is specifies the standards for proximity cut standards, like the range which it is acceptable for the communication and such things. It also specifies the physical characteristics, for the radio frequency interface and communication protocols for proximity cards and how the readers will use to interact with them. It is widely used in various applications. The second protocol being the EPC Gen 2. The EPC is Gen 2 is the aftermath of EPC Gen 1. EPC, also called Electronic Protocol Product Code Generation 2, is a standard for RFID technology. It specifies the communication between RFID readers and Gen 2 compliant RFID tags. So this is used in supply chain management, logistics, inventory tracking, and various other applications. The EPC Gen 2 RFID offers primarily the UHF radio frequency band, that is the ultra high frequency band, which is typically in the 860 to 960 megahertz range. This is another example of a protocol for radio frequency communication in the EPC Gen 2 protocol. Now the next one we will be talking about is Bluetooth. As we all are familiar with Bluetooth and RFID, though they are distinct wireless technology, but they can be incorporated. Each has its own set of characteristics and use cases. There are scenarios where these technology can complement each other to create a more robust and versatile solution. So the Bluetooth can extend the range of RFID reader, the application, the advantages of being complementing each other, and the Bluetooth Low Energy BLE is a power efficient version of Bluetooth that is well suited for battery powered devices. And the Bluetooth can enable the creation of mobile apps and user interfaces that provide a seamless and user-friendly experience. So, when incorporated Bluetooth with RFID, the communication can be seamless, and each characteristics of their own, though distinct, can be combined together for better communication. So, moving on to RFID tracking in healthcare. RFID has numerous applications in healthcare industry, as we all know. It has many benefits by cutting operational costs. Workmen can be detected at a great extent. It can be used for inventory management or the streamlining hospital workflows, reducing medical errors and such. So it is of great importance if we use RFID in healthcare. So given is a real world example of how an RFID could be used in a hospital. So the architecture shows the RFID tags, which is in constant communication with RFID readers. The RFID readers is connected to a cloud server, which is protected by a firewall. So it shows that the security of such systems are well guarded. So the cloud server includes the streaming of the data processor, the data lake, the data warehouse, and the data analytics, which is then connected to medical staff application and the admin application. Moving through the components, we have the RFID tags, which is attached to or embedded into hospital assets or tracking bracelets, or it could be bracelet or badge, and it could be used for both patients, visitors, staff, and can be used to transmit information on their location to whatever RFID readers are around. The RFID readers can be located anywhere in the hospital, like corridors, wards, etc. And it is very used in patient tracking and has similar other applications. The firewall is for security, as mentioned earlier. It securely transmits collected data to the cloud server. And the streaming data processor is to transfer the input data from about hospital assets. The data lake stores the data about the track patient staff, etc. And the big data warehouse store the filtered and the pre-processed data for further analysis of hospital staff. It also works for the workflow efficiency in the movement of patients, medical asset utilization, etc. The data analytics identify patterns and tendencies in hospital asset use and movements of tracked people and provide insight aimed at improving asset availability. So, analytics basically analyzes the data that is fed to the cloud server through various tags and readers that is attached all around the hospital. So, analysis takes place in the specific region, and the software business logic process all these requests according to the higher priority. We can pre-assign the priority of events and find out what information are to be dislodged accordingly. Next is staff application and admin application. These being enabling the staff to view locations of various patients or the even assets. We can even edit data about tracked items and people and grant access to asset tracking system for the medical and administrative staff. So these are the various applications that we will be talking about. Patient identification, tracking patients, medication management, infection control, asset tracking, inventory management, patient flow and wait time management, temperature monitoring, blood tissue tracking, and emergency response. The most common used method for patient identification using RFID is by implementing wristband RFID tags. So, patients are typically provided with a bracelet that has a specific RFID tag inbuilt in it. So, it enables the use of seamless communication without the um, and we are talking about the difference between RFID and barcode and why RFID is better than barcode of with the uses like read rate where RFID is thousands of tags in a single minute, and the line of sight is not required, the read and write capability, and the security. So the medication management is really important in a hospital since medicines are to be provided at the right time to the right person. So the double checking without the wastage of time could be ensured with the use of medication management by RFID system. Inventory management. The real-time management of inventory is really hard. So when indulged in RFID, inventory around the hospital with the thousands of people involved can prevent stockouts and expired medication. Now the advantages. The advantages include patient safety, patient optimization, infection control, medication management, etc. The limitations of RFID, though it exists, can be used for future scope, or there are areas of future development. So in conclusion, we can say that by integrating RFID technology, we can enhance patient safety, reduce administrative errors, improve asset management, and provide more efficient and effective healthcare system.